moments in conceptual mobility design when scale alone is not what commands attention, but rather proportion, disciplined by intent. And this motorhome immediately presents itself as an exercise in controlled mass rather than excess. Before I go any further, it is important to state clearly and respectfully that what we are examining here is a fictional AI-generated design study created purely for imaginative exploration. It does not exist as a production vehicle, nor as a physical prototype. However, for the purposes of design analysis, I will approach it with the same seriousness and engineering scrutiny I would apply to a full-scale concept revealed behind closed doors at an international auto salon. Standing in front of this vehicle, the first observation is its sheer dimensional authority. Proportionally, I would estimate a length in the region of 13 to 14 meters, with a height approaching 4 meters when accounting for the roof-mounted modules. The width appears close to the regulatory maximum for heavy-duty vehicles, likely around 2.5 meters, yet the surfacing makes it feel narrower due to its horizontal emphasis lines. The stance is exceptionally deliberate. We are looking at a triple-axle configuration at the rear with a single front steering axle, creating a six-wheel rear load-bearing architecture. That decision alone signals a design philosophy rooted in structural realism. A motorhome of this volume, particularly one with a double-deck glass section and rooftop systems, would demand distributed axle loading to maintain both stability and regulatory compliance. From an engineering standpoint, the triple-axle configuration solves several challenges simultaneously. It reduces point load stress on the chassis rails, allows greater gross vehicle weight capacity, and enhances longitudinal stability at highway speeds. In real-world use, this would translate to reduced pitch under braking and improved composure when encountering crosswinds. The wheelbase appears exceptionally long, likely over 8 meters between the front axle and the final rear axle. This extended wheelbase would naturally support interior spatial continuity, but it also introduces turning radius challenges. One would assume rear axle steering integration would be necessary in a real engineering scenario to mitigate urban maneuvering limitations. Now, let us examine the exterior architecture more closely. The surface language is distinctly armored, yet refined. The front fascia adopts a geometric, almost parametric logic, with sharp planar transitions intersecting at disciplined angles. This is not decorative aggression, it is structural expression. The bumper integrates reinforced lower elements that appear engineered for impact resistance rather than aesthetic posturing. The grille treatment is fascinating. It abandons the traditional open cooling paradigm of combustion-based motorhomes and instead uses a tightly meshed, almost shield-like fascia. If this were a hydrogen-electric hybrid platform, as the packaging suggests, cooling would be modular and ducted rather than reliant on a large frontal aperture. The headlamp architecture is layered and hierarchical. We see vertically stacked LED modules that likely serve as primary beam units, with horizontal daytime running lights positioned above in a narrow strip. This layered lighting identity creates visual width while maintaining vertical authority. At night, the signature would be unmistakably architectural rather than automotive. The glass-to-body ratio along the side profile is particularly bold. The upper deck is almost yacht-like in its panoramic glazing. Structurally, this introduces torsional rigidity concerns because large, uninterrupted glass areas reduce the structural contribution of side pillars.
In a realistic scenario, the vehicle would require high-strength composite reinforcement within the A, B, and C pillars, potentially using carbon fiber reinforced polymers or ultra-high-strength steel alloys to compensate. What this achieves experientially, however, is spatial liberation. From inside, occupants would feel elevated and visually connected to their environment in a way traditional RVs rarely achieve. The trade-off becomes thermal management. Such glazing would necessitate electrochromic tinting and multi-layer acoustic lamination to maintain climate control and noise isolation. Aerodynamically, the vehicle is more disciplined than one might expect at this scale. The roofline subtly tapers rearward. The upper deck overhang is not abrupt. It transitions with controlled curvature continuity, reducing airflow separation. The chamfered edges at the front corners likely function to deflect high-pressure air around the cabin rather than allowing turbulent buildup. The lower body cladding appears functional rather than ornamental. The angular protrusions around the wheel arches may serve to channel airflow away from rotating tire surfaces, reducing drag-inducing turbulence. For a vehicle of this height, managing aerodynamic drag would be critical for energy efficiency, particularly if operating on a hybrid electric system. The paint finish deserves attention. The body tone appears to be a layered matte metallic graphite, possibly incorporating ceramic-infused clear coating for thermal reflection and scratch resistance. The contrast between satin and gloss sections suggests a multi-material body, perhaps aluminum panels over a reinforced structural frame. Light diffuses across the surfaces rather than reflecting sharply, which enhances the perception of solidity. Now, the roof system is where the conceptual ambition becomes most evident. We observe integrated solar panels positioned flush within a raised aerodynamic housing. These panels are not simply placed atop the roof, they are embedded within a structured enclosure that likely protects them from debris while optimizing angle exposure. Additionally, the spherical module near the rear roofline suggests a satellite communication dome or advanced sensor array. If this were a semi-autonomous, long-range touring platform, roof-mounted LiDAR, radar, and satellite connectivity systems would be positioned precisely here to maximize unobstructed signal reception. The structural implication of such roof hardware is weight concentration at the highest vertical point. To counteract this, the chassis would require a low-mounted battery pack to maintain a favorable center of gravity. In practice, this would improve rollover resistance and highway stability. Let us address the entry system. The deployable staircase integrates seamlessly into the lower body architecture. This suggests a focus on theatrical arrival without compromising structural continuity. The stair housing appears reinforced, indicating it could support significant load without flexing, important for long-term durability.
The wheels are large diameter, likely 20 to 22 inches, wrapped in all-terrain tires with moderately aggressive tread. This indicates the vehicle is engineered for mixed surface confidence rather than extreme off-road articulation. The rim design is aerodynamic yet robust, with minimal open spokes to reduce drag while maintaining brake cooling capability. Suspension philosophy would almost certainly involve adaptive air suspension. A vehicle of this weight class would benefit from load-leveling systems capable of adjusting ride height depending on terrain or campsite leveling requirements. In real-world use, this would dramatically improve comfort and usability. From a segment perspective, this concept redefines the motorhome category by borrowing visual language from expedition trucks, aerospace modules, and high-end architectural pavilions. It does not resemble conventional RV architecture, which often prioritizes box-like efficiency over sculptural integrity.
Here, the design maturity suggests a luxury positioning tier far above mass-market recreational vehicles. The intended user archetype is likely a long-range explorer who values technological autonomy as much as spatial comfort. My first professional impression is that this is less an RV and more a mobile architectural installation engineered for sustained independence. Given the exterior volume and deck height, the interior architecture would almost certainly adopt a dual-level spatial strategy. The lower deck would house primary living functions, kitchen, lounge, washroom, while the upper deck serves as either panoramic lounge space or sleeping quarters. Structurally, the floor between decks would need to function as both a load-bearing element and a vibration isolator. Composite honeycomb sandwich panels would likely be required to maintain rigidity without excessive weight. Ceiling height on the lower deck appears generous, likely near 2.1 meters, while the upper deck might taper slightly to preserve aerodynamic efficiency. Sleeping quarters would logically be positioned toward the rear upper section, where road noise and engine vibrations are minimized. The extensive glazing would provide dramatic views, but privacy would require electrochromic glass or retractable insulated panels. Thermally, multi-zone climate control would be essential to prevent heat stratification between decks. The kitchen engineering would need to prioritize compact efficiency. Induction cooking surfaces would reduce open flame risk and energy waste. Integrated refrigeration drawers rather than full-height units would maintain lower center of gravity mass distribution. Water storage would likely be positioned low within the chassis rails to prevent sloshing instability. In terms of washroom design, a modular separation system would be more plausible than a single wet bath. Graywater recycling would extend off-grid endurance, especially if integrated with advanced filtration systems. Ventilation would require negative pressure airflow management to prevent humidity migration into living zones. The cockpit appears commanding and upright. Visibility through the expansive windshield would be exceptional. A semi-autonomous driving suite with augmented reality overlays projected onto the glass would align with the technological ambition suggested by the roof sensors. Energy architecture is perhaps the most intriguing dimension. A hydrogen-electric hybrid system would allow extended range without the mass penalty of purely battery electric propulsion. High-density battery packs positioned low along the chassis would support regenerative braking and solar energy capture. Solar contribution from the roof panels, realistically, would supplement auxiliary systems rather than propel the vehicle independently. However, for off-grid living, it would meaningfully extend autonomy for climate control and onboard computing systems. Smart systems would include climate zoning, predictive maintenance diagnostics, and satellite-based connectivity for remote navigation. Structural health monitoring sensors embedded within the chassis could detect stress fatigue over long journeys. In lifestyle terms, this concept supports long-distance touring across continents rather than weekend camping. Its mass and scale would limit dense urban maneuverability, but for expansive highways and remote landscapes, it would offer unmatched independence. From an engineering feasibility standpoint, several advancements would be required to bring such a concept into practical existence. Lightweight composite manufacturing at this scale would need to become more cost-efficient. Hydrogen infrastructure would need broader availability. Autonomous driving software would need to handle heavy vehicle dynamics reliably. Is this evolutionary or revolutionary? I would argue it is evolutionary in architecture, but revolutionary in integration. It synthesizes existing technologies, solar, hybrid propulsion, and smart connectivity into a singular, cohesive mobility vision. Ultimately, what makes this design compelling is not spectacle but intention. It proposes a future where luxury mobility is defined not by ornamentation, but by structural intelligence and autonomous capability. And that raises a question worth contemplating. If engineering constraints continue to dissolve under material science innovation, how different might long range living become from fixed architecture itself?